In this video, we will learn how to solve equations involving complex numbers in rectangular form. In this example, we have to solve for the complex number x given this equation. Upon inspection of this equation, this looks like a quadratic equation, whereby you have an x squared term, x terms, and then a constant term, and that's equal to 0. So the first thought that comes to my mind would be to solve it using the quadratic formula later. But before that, let me rewrite the equation so that it becomes quadratic in form. So I have x squared plus, take out the x from these two terms, and I get 1 plus j2, and then plus j, and that's equal to 0. Once I've written it into this form, I can identify the a, which is the coefficient of x squared, and that's 1. B is the coefficient of x, which is 1 plus j2, and c is the constant term, which is j. Now I can use the quadratic formula to solve for x, which is minus b plus minus square root of b squared minus 4ac over 2a. And because I have identified a, b, and c, I can just put it into the formula. Now I'm going to simplify this. Inside the bracket, 1 plus j2 entire thing square would be 1 plus j4 plus j squared 4. Within the square root, j4 and j4 minus each other out. And j squared 4 will be equal to, what is j squared 4 equal to? Correct, because j squared is negative 1, j squared 4 is negative 4. So I have 1 minus 4 inside the square root. Now let's simplify what's in the square root. I get negative 3. Now let me continue on the other side. I'm going to write square root of negative 3 as square root of negative 1 times square root of 3. And now that we learned complex number, we know square root of negative 1 is just j. So I have two possible answers. The first answer is negative 1, negative j2 plus j square root 3 over 2, or negative 1, negative j2 minus j square root 3 over 2. I'm almost at the end of the working. All I need to do now is to separate the real parts from the imaginary parts. So I have minus half plus j bracket negative 2 plus square root 3 entire thing over 2. And the other answer would be minus half plus j bracket negative 2 negative square root 3 the entire thing over 2. So these are the two possible answers for x. In this example, you have to solve for complex number x given this equation. This equation is different from what we had earlier. It does not look like it's a quadratic form. So what I'm going to do is to try and make x the subject of the equation and thereafter solve for it. So first thing, I'm going to copy down the equation as given. And then I'm going to bring the negative 1 minus j to the right hand side. So I have x plus 3 equals x minus 1 multiplied to minus 1 minus j. Then I'm going to expand out these two pairs of brackets. So I have negative x plus 1 minus jx plus j. Then I'm going to bring all the x terms to the left and push all the non-x terms to the right. So I have x plus jx. On the right hand side, I have 1 plus j minus 3. Take out the x like a common factor. At the same time, I tidy up the right hand side. I'm going to move the 1 plus 1 plus j to the right hand side by doing a division. At the same time, 1 plus 1 is 2, so 2 plus j at the denominator. Now it seems like I have a complex number divided by another complex number, and we have learned earlier how to carry out this division. In order to carry out this division, I need to think about the conjugate of the denominator. What is the conjugate of the denominator 2 plus j? You're right, it's 2 minus j. So I'm going to multiply by 2 minus j to the top as well as to the bottom. Now I'm going to expand out the numerator as well as the denominator. So this times this will be minus 4 plus j2 plus j2 minus j squared. That's in the numerator. At the bottom I have 4 minus j squared. Let me continue the working over here. So x is equal to, tidying up the numerator, I have minus 4 plus j4 minus j squared, which is minus 1. At the bottom, I have 4 minus j squared is minus 1 again. So this becomes negative 3 plus j4 over 5. I'm almost done. Now I just split up the fraction to reveal the real part and the imaginary part. So the answer is this for x. In this example, we have to solve for complex number x given this equation. In this equation, we have x and we also have conjugate of x. In an equation such as this, where the unknown complex number x exists alongside its conjugate, we have to solve it by letting the complex number x be a plus jb, where a and b are two real numbers whose values we have to find. If x is a plus jb, then what will x conjugate be? That's right, x conjugate will be a minus jb, because we will keep the real part unchanged, but change the sign of the imaginary part. Now that we know what's x and x conjugate, I'm going to substitute into the equation given. So x becomes a plus jb, x conjugate is a minus jb, x conjugate again, a minus jb, 2 times a plus jb minus j. Let me tidy up the equation here. Expanding these two, I have a squared minus j squared b squared. Multiplying 2 inside, this is what I get. Let me simplify some more. J squared is negative 1, so this becomes a squared plus b squared. Now I observe that I have an equation where there are real parts as well as imaginary parts on both the left-hand side and the right-hand side. So what I'm going to do is to equate real parts as well as imaginary parts later. So let's start by equating real parts. On the left-hand side, the real parts are a squared plus b squared plus a. These are the real terms. On the right-hand side, 2a is the only real term. Let's tidy this up. A squared plus b squared equals to a. This is called equation 1. Next, I will equate the imaginary part. Left-hand side, the imaginary part is minus b, this one. On the right-hand side, 2b minus 1. And this can solve for b straight away. b is 1/3. And since we know b is 1/3, I can substitute b as 1/3 into equation 1 straight away. So a squared plus 1/3 squared equals to a. I get a quadratic equation in terms of a. And upon solving, a has two values, 0.873 or 0.127. Therefore, we have found x. x can be 0.873 plus j 1/3, or x can also be 0.127 plus j 1/3. These are the two possible answers for x.